Unit 17, Part 4, I'm not going to go through this whole proof now. I just wanted to give you a taste of the level of complexity of the sentences involved in the proof we started with, right? That relational predicate logic will give us the resources to be able to prove. The complexity of the sentences and the extra complexity and the manipulations that are going to be required to be able to prove, for example, this conclusion from these premises. Okay, so it would be crucial to pay attention to the it would be, once again, extra crucial to pay attention to the form of the sentences, right? To grasp that this was, as I said, a existential statement, as was the conclusion, which means that EI, or the instantiation rule, and EG, the generalization rule, are possible to go from the first premise to get to the conclusion. Please notice also that these two, right, working top down, this was an EI on one, right, flag A, you would be flagging A. And also notice this one here, which we got from working backwards by doing the opposite instantiation, and we're going to be EGing from this to this. What's the form of these two? They are conjunctions, notice, and the conjunctions, the left conjunct in both are the same, is PA. This is a conjunction, right? Which means what? The rule you're going to think of is the rule governing conjunctions, which is what? Simplification, right? So from here, you're actually going to go PA, simp from here, and the second conjunct, which you simplify to, is the universal statement for all y, dy hook not LA, right? That'll be a universal. You've simplified to a universal statement, and this one you will be able to, since it is in quantifier form, do a UI from, okay? This one, which is the it, right, dot, 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 there's lots more in the middle here, which I won't go through, some more. Right. This was the one at the bottom of the proof, right? This is the second last step of the proof. We got it and its form from doing the opposite of instantiation, right? We figured out this was the instance we need. What is its form? It's a conjunction. What rules allow me to infer conjunctions? The rule of conjunction, right? So I'm going to get PA separately, and this universal statement, not quite this one, that's dy, that's uy. I'm going to get this one, this other thing that I need to form the conjunction. I've already got the left conjunct, right? So I've already got the left conjunct there, PA, but I'm going to get the second one, right? That's for all y, if uy, then not L, A, Y. I'm going to get that by universal generalization, right? The second conjunct I'm going to get by UG. Okay, so anyway, we'll see how all that goes. But that's where we're heading, right? That's how complex our formulas are going to be. We're heading for the formulas. Formulas are the logical or symbolic representation of our English sentences. Our sentences making up the arguments we're trying to prove. But let's slow down and go back to the beginning. So we're introducing relational predicates like loves. Okay, so let's just look at the syntax. Syntax are just the rules for forming formulas, right? What are and what are not legal formulas, right? So the syntax for the dot, right, for the sentential operator and was, you've got to have a legal formula on the left and a legal formula on the right. You can conjoin them, and that's the rules. You can't have blank and blank and blank officially, because the syntax says it's a two-place sentential operator, right? Or the negation is a one-place sentential operator. You can't have not A, B. Thinking back to sentential logic, right? That's syntactically not allowed, right? Why? Because that's a one place, right? The syntax says you have made a legal formula so long as you put a legal formula in here. join it with negation, that's legal. This can be A and B, or A or B, brackets, right? So on and so forth, right? Okay, so there's syntax, there's rules for constructing formulas for these relational predicates. So take loves, right? That's going to be our paradigmatic, that's Klenk's paradigmatic relational predicate, right? What's the linguistic being of the English word love? It's a relation, right? You could say Bill loves, but more properly, Bill loves Jane, right? It's a relation between one, usually person, and another person. Okay, so it's two-place. So the correct ontology of loves is a two-place predicate, right? So you think L blank blank, right? Space space. Now, what kind of ways are there to complete this? So remember back to unit 10 when we introduced quantifier logic, predicate logic. I said, why is predicate logic so cool? Because if you take a propositional function, there were different ways to complete that propositional function and get a sentence. Right? Remember a propositional function, AX equals X is Australian. It's not a sentence in and of itself. It's not itself true or false. It needs to be completed in some way to be. It is incomplete in itself. It needs some kind of completion to be a sentence, to be something that is capable of being true or false. Two ways you can do so. You can replace the variable, the individual variable, with an individual constant, right? Replace X for D, and you move from X is Australian to Dan is Australian, which is true or false, right? It is a sentence. But the other way, and this was the really cool bit, was you could combine the propositional function with a quantifier. There we had one place predicates, and you could only have one variable. Here we're going to have, since we've got two place variables, there's going to be there's going to be many more possible combinations, right? We're going to be able to annex a relational predicate. We can combine it with two quantifiers, or one quantifier, or zero quantifiers. It's a short way of saying it. Now we'll see it in more detail. Okay, so the most basic way to make a sentence with the relational predicate loves is to fill those two places in with individual constants, right? So just LXY, right? LXY, that's the propositional function. That's how you would state the propositional function. X loves Y. Now, let A be the individual constant standing for Andrew, B be the individual constant standing for Betty. LAB, like that, is how you say Andrew loves Betty, right? And notice that that's how it is. The syntax is properly the capital letter, right? The predicate letter, and then the first individual, the second individual. Notice, very importantly, that the order matters, right? LAB is Andrew loves Betty. Oof, I have to tip everything over here. LAB does not equal LBA, because what does this say? This says Betty loves Andrew, right? LXY defined as X loves Y, right? So whatever's in the first place, whatever's in the first position is the lover, and whatever's in the second position is the lovee. And as I'm sure you all know from experience, to love is not the same as to be loved by some particular person, right? So those are very different in meaning, right? So you really do have to pay attention when you're translating to which order is going on here. Notice this is the correct the correct way to write. So to translate these. So if you're asked to translate, so in English, Andrew loves Betty. You've got the first name, then the loves, and then Betty. But you do not write A L B. That's wrong, right? You don't write. So it's A, little a, big L, little b. Very, very neatly. You don't write that. That's wrong. It's no good. You don't write these. You don't write. That is not how you define the propositional function. You can't write x, l, y for x loves y. It's always predicate letter, first position, second position. It's just relational. And we're going to have three-place. We're going to have occasional use for three-place propositional functions, right? Three-place predicates. It's monadic, many-place predicate propositional functions. So this is how you write. This is B, A, B, C, or B, X, Y, Z. With three places like that, could be the propositional function X is between Y and Z, right? X is between Y and Z. Notice that these are correct. So A, B, C, right? Chicago is between New York and Boston. If A is Chicago, B is New York, and C, let's C is Los Angeles. Sorry. Right. Forget the letters, but that's how you write it. So A is between B and C, right? You don't write it like this. You don't write A, B, little b, C, right? That's wrong. It's got to be predicate letter and then the three things in this case, right? Also notice, so for loves, just continuing on the syntax, loves is properly a two-place predicate. So it's L bang bang. There's only two, right? There's only two spaces, not three, which means the following is wrong, right? You don't. So how do I say Dan loves Eden and August, right? It's a conjunction of Dan loves Eden and Dan loves August. You cannot symbolize Dan loves Eden and August like this, right? What's correct? This is correct. Right? Because love is only two-place, you've got to have, right? To say Dan loves Eden and August, you have to grasp it as a conjunction of Dan loves Eden and Dan loves August. Because according to our definitions, love is just a two-place predicate, not a three-place, right? So that's right. Conjunction of LDE, D for Dan, E for Eden, Dan loves Eden, and LDA, Dan loves August, right? You've got two places and you filled them out both times, that's correct. Both of these are wrong, which students are tempted by, as Klenk says. This is uppercase L, lowercase d, E, dot A. No, you can't have conjunctions down here. Conjunctions, there's still some syntax. There is still a syntactical law for conjunctions. Has to be legal formula on left, legal formula on right. Just A is not a legal formula, not a sentence. A is an individual constant, like propositional functions. It's not true or false of itself. It's not a complete sentence. It's not a complete sentence or formula. So that's not legal. You can't have a conjunction where one of the conjuncts is just an individual constant. No. And this is no good either. You can't run on the beings I love like this, right? You can't have LDEA for Dan loves Eden and August. Why not? Because you've treated loves as if it's a three-place when we've defined love as a two-place predicate. We've treated it as if it's three-place, but there's not three places, there's only two. So if we're defining loves as a two-place predicate, you've got to stick to that syntactical rule.